December 1955. A conference room in Pittsburgh, Pennsylvania. Ralph Kress, a 51-year-old engineer with grease under his fingernails and a reputation for thinking differently, sat across from executives at Westinghouse Air Brake Company, WABCO, as everyone called it. They had a problem, and they knew Kress might be the only man in America who could solve it. WABCO had spent the better part of a century building air brake systems for railroads. Reliable work, profitable work. But 2 years earlier, they'd made a gamble that was starting to look like a mistake. They'd purchased R.G. Letourneau's entire construction equipment business, scrapers, rubber-tired dozers, the whole operation. The idea was simple: diversify before the railroad business contracted. But diversification only worked if you could actually compete. And WABCO couldn't compete. Not in scrapers, not in dozers. Euclid was crushing them in the market, and Caterpillar wasn't even breaking a sweat. Every month brought another disappointing sales report. Every quarter showed the same story. They were bleeding money in a business they didn't understand. But one corner of the mining industry caught their attention. The big open-pit copper mines out west, the iron ore operations in the Midwest, the coal mines eating through entire mountains, they all needed the same thing: trucks. Big trucks. Trucks that could haul tonnage that would snap the frame of anything running on a highway. And nobody was building exactly what the mines needed. Euclid had trucks, International Harvester had trucks, Mack had trucks. But they were all essentially highway trucks on steroids. Beefed up frames, bigger engines, wider beds. Take a road truck, make it tougher, paint it bright green or orange, call it a mine truck. That was the formula. And it worked well enough that Euclid dominated the market with a stranglehold that seemed unbreakable. The mining companies weren't exactly thrilled with what they were getting. The trucks bounced operators around until their kidneys ached. Frames twisted and cracked on uneven pit floors. Leaf springs stacked a foot high would flatten out after a few thousand loads, requiring constant maintenance. The long wheelbases made maneuvering in tight pit spaces an exercise in patience and profanity. But what choice did they have? You bought what was available, or you didn't haul rock. Ralph Kress had been thinking about this problem for years. He'd spent 5 years running Dart Truck Company in the early 50s, where he learned that most engineers approached truck design from the wrong end. They started with the powertrain and built outward. Ralph Kress started with the rock. What does the rock need? It needs to be loaded efficiently, transported quickly, and dumped completely. Everything else was secondary. If you started from that principle, suddenly the entire truck looked different. But Kress didn't just want to build a better truck. He'd already done that at Dart, where he'd created larger machines by being the first to put power steering on every truck as standard equipment. Not an option, standard. That simple decision let him design bigger trucks because operators could actually steer them. While competitors were still building trucks that required 2 strong men to turn the wheel, Dart trucks responded to a single finger. Caterpillar had noticed. They'd offered Kress a position which he'd turned down. He had his own ideas about where mining trucks needed to go, and he wasn't ready to execute someone else's vision. So when WABCO came calling in the late 1955, offering him a consulting contract and a blank sheet of paper, Kress said yes. The deal was straightforward. WABCO would give him complete design freedom and the resources of a major corporation. In return, Kress would deliver a truck that would make mining companies forget Euclid existed. He went to work immediately. His office in Peoria, Illinois became a war room plastered with sketches, calculations, and photographs of mining operations. He visited pit mines throughout the Midwest, watching how trucks actually worked in the field, not how they were supposed to work according to engineering manuals, but how they actually performed when driven by tired operators over terrible roads for 12-hour shifts. What he saw confirmed what he'd suspected. Every problem with existing mine trucks came back to the same source. Engineers treated tires as if they were part of the suspension system. They were not. Tires were contact patches. They transmitted force. Yes, they flexed and absorbed some shock, but asking rubber to be your primary suspension component in a mine truck was like asking a crowbar to be a pillow. It might work for a highway truck running on pavement at steady speeds. It absolutely did not work when you dropped 15 tons of copper ore from a shovel bucket 8 feet above a truck bed, or when you hit a boulder at 20 miles per hour that would rip the axle off a highway truck. This realization became the foundation of everything else. If tires weren't suspension, then the truck needed real suspension. Not leaf springs, those were just slightly more sophisticated than no suspension at all. Something that could actually absorb shock, dampen oscillation, and keep the frame from twisting into a prensil. Kress had seen hydropneumatic suspension systems in aircraft landing gear, nitrogen-charged oil cylinders that could handle massive shock loads while providing variable resistance. They were expensive, complex, and nobody had ever successfully adapted them to an off-highway truck. Nobody had tried hard enough. By the time Kress presented his complete design to WABCO executives in early 1956, he'd reconceived every aspect of the mine truck. The short wheelbase would give it agility Euclid trucks couldn't match. The deep V-shaped dump body would sit lower, making it easier for shovel operators to load while keeping the center of gravity down. The kinked frame would accommodate the body shape while maintaining structural integrity. And the hydro-pneumatic struts at all 4 corners would revolutionize ride quality and frame longevity. WABCO management looked at the drawings and saw something else. A truck that didn't look like anything else on the market. It looked purposeful, aggressive, like it had been designed by someone who actually understood what happened in a mine. They approved full-scale development. The prototype would be ready by late 1956. If it worked, they'd have their flagship product. If it failed, WABCO's construction equipment division would probably be sold off for scrap value. Ralph Kress didn't plan on failing.
December 1956. The prototype rolled out of the Peoria plant looking nothing like a typical mine truck. Where Euclid trucks sat tall and narrow, this machine squatted, wide and purposeful. The massive steel collar running a third of the way back from the front bumper was impossible to miss, a structural element that would become the signature of every large mining truck built for the next 70 years. The engineers who'd built it under Kress's direction called it the LW30. 30 tons of rated capacity, powered by a 450 horsepower Cummins diesel hooked to a torque converter transmission. But the capacity rating was conservative. Everyone knew it could haul more. They also knew that didn't matter if the suspension system didn't work. Traditional mine trucks use stacked leaf springs at each corner, heavy steel plates that look like they've been borrowed from railroad freight cars. They absorbed shock through crude and mechanical deflection, and they wore out at an alarming rate. In really rough service, mines might replace spring packs every 6 months. The maintenance was endless, and every hour a truck spent getting new springs was an hour it wasn't hauling rock. Kress's Hydrair system worked on a completely different principle. Each corner of the truck had a nitrogen-charged oil cylinder. When the wheel hit a bump, hydraulic oil forced its way through calibrated orifices, compressing the nitrogen gas. The gas acted as a spring, but unlike steel springs that had a fixed rate, the nitrogen compressed progressively, soft for small bumps, firm for large impacts. The oil flow through the orifices provided damping, absorbing energy instead of letting it bounce back into the frame. WABCO's patent office had already filed paperwork on the design. They called it Hydrair, and they knew that if it worked, every other truck manufacturer in the world would eventually have to either license it or design around it. The patent was that fundamental. But patents didn't matter if the truck couldn't survive real work. In early 1957, before the official production launch, Kress and the WABCO team took the prototype to a copper mine in Arizona for field testing. The mine manager was skeptical. He'd seen prototypes before. Usually they worked great in the factory and fell apart in the pit. 3 months later, that same manager was ready to order 10 trucks immediately. The LW30 wasn't just better than his Euclid trucks, it wasn't even in the same category. Where his operators complained about being beaten up by 8 hours in a Euclid, they fought over who got to drive the WABCO. The Hydrair suspension absorbed impacts that would have sent shockwaves through a conventional truck's frame. Operators arrived at the end of their shifts without the lower back pain that had been considered an occupational hazard. More importantly, the truck itself was surviving. Conventional mine trucks developed cracks in the frame within the first year of hard service. Welders spent endless hours patching and reinforcing. The LW30's frame showed minimal stress. The structural collar distributed loads, and the Hydrair struts prevented shock spikes from hammering the frame. And the deep V-shaped body was working exactly as designed. The load centered itself automatically, and when the hydraulic hoist raised the bed, material slid out completely instead of sticking in corners. The name Haulpack appeared later that year when Laterna Westinghouse, the corporate name hadn't changed to just WABCO yet, needed something memorable for marketing. Someone suggested it as a combination of haul and pack, though others claimed it referenced the packaging of advanced features into a single truck. The origin didn't matter. What mattered was that the name was short, memorable, and sounded like it meant business. The first production Haulpack rolled off the line in November 1957, a 32-ton rated capacity truck. The official debut came shortly after, when that truck led Peoria's Thanksgiving Day parade before driving to the Midland mine 25 miles west of town. Local newspapers covered the parade, noting the unusual sight of a mine truck decorated with streamers and banners. Mining industry journals covered the technical specifications. Euclid's executives read those specifications carefully. Then they read them again. Then they started making phone calls. The Haulpack's short wheelbase gave it a turning radius 20% tighter than Euclid comparable trucks. The Hydrair suspension allowed it to run 10 miles per hour faster on rough haul roads without shaking itself apart. The deep body meant it carried its rated load with a lower profile, improving stability. And the whole package weighed less than Euclid's equivalent truck, which meant lower cost per ton mile. By mid-1958, mining companies were asking their Euclid dealers when Euclid would have an answer to the Haulpack. The dealers had no good response. Euclid's engineering team was scrambling to develop a competitive suspension system, but WABCO's patents blocked the obvious solutions. They'd have to design around the Hydrair concept, which would take years. Meanwhile, WABCO was scaling up production and expanding the line. They introduced a 25-ton model for smaller operations, then a 42-ton model for the big copper mines. Each size followed Kress's core design principles: short wheelbase, deep V-body, Hydrair suspension. The family resemblance was unmistakable. The mining industry's response was immediate and enthusiastic. By 1961, WABCO offered 5 models ranging from 22 to 60 tons. The Haulpack wasn't just a successful product, it had become the reference standard that every other manufacturer had to match or beat. But success bred competition in ways Ralph Kress hadn't anticipated. In 1959, a small company in Tulsa, Oklahoma called Unitrig decided to try something radical. Instead of challenging the Haulpack's mechanical drive system head-on, they'd go around it. They partnered with General Electric to develop a diesel-electric drive where the engine powered a generator and electric motors in the wheels provided propulsion. The concept wasn't new. Diesel-electric locomotives had used it for decades, but nobody had successfully adapted it to mine trucks. The motors had to fit inside or behind the wheels, transmit massive torque, and survive conditions that would destroy industrial equipment: mud, dust, temperature extremes from below 0 to 120 degrees, and shock loads that would crack cast iron. GE's engineers spent 3 years developing a motorized wheel that could survive mine service. When they succeeded, Unitrig built it into a truck that would eventually challenge Haulpack's dominance in large-capacity machines. But that threat lay in the future. Through the early 1960s, Haulpack ruled the mining industry. Then Ralph Kress made a decision that changed everything. For Haulpack, for mining trucks, and for the competition that thought they'd finally figured out how to catch up.
February 1962, Ralph Kress walked into Caterpillar's headquarters in Peoria, the same city where he'd revolutionized mining trucks 5 years earlier, just on the other side of town. Caterpillar had been watching the Haulpack decimate Euclid's market share, and they wanted in on the mining truck business. But they didn't want to build just another mechanical drive truck. They wanted to leapfrog WABCO entirely with electric drive, and they needed someone who understood both mine operations and advanced engineering. They offered Kress something WABCO never had: unlimited resources and the full might of the world's largest construction equipment manufacturer. He accepted.
For WABCO, losing Kress was like losing their compass in the middle of the ocean. The trucks he'd designed were selling faster than they could build them, but nobody at WABCO truly understood his design philosophy. They had the patents, they had the manufacturing drawings, they had the production lines. What they didn't have was the vision that had created it all. But they had momentum, and in manufacturing, momentum could carry you a long way. The Haulpack line continued expanding through the 1960s. A 65-ton model appeared, then an 85-ton monster that required special tires Goodyear developed specifically for it. Each model maintained Kress's original design DNA, that distinctive kinked frame, the deep V body, and the Hydrair suspension that had become synonymous with ride quality. The mining industry was changing in ways that perfectly aligned with Haulpack's strengths. Copper mines were getting bigger, iron ore operations were scaling up. The machinery loading these trucks, cable-operated shovels giving way to hydraulic excavators, could fill a truck bed in 3 passes instead of 6, but only if the truck could handle the shock of 15 tons of rock dropped from 10 feet up, multiple times per load cycle, hundreds of times per shift, day in and day out. Conventional leaf spring trucks couldn't take it. The springs would sag, the frames would crack, and the maintenance costs would destroy any productivity gains from faster loading. But Haulpacks absorbed the impacts and kept rolling. Mine after mine switched their fleets from Euclid green to Haulpack's distinctive colors. Then, in 1964, the industry learned something important. Ralph Kress hadn't forgotten about WABCO just because he'd left. When Caterpillar introduced their first off-highway mine truck that year, the 769, it looked remarkably similar to a Haulpack. Short wheelbase? Check. Deep dump body? Check. Frame design that minimized stress concentration? Check. The only major difference was the suspension system, which couldn't use Hydrair because WABCO still held the patents. Caterpillar's solution was elegant. They licensed their own hydropneumatic suspension technology from another source and refined it for mining service. It worked almost as well as Hydrair, and more importantly, it worked well enough that Cat could now compete for the same customers WABCO had dominated. The competition was exactly what the mining industry needed. Prices stabilized, innovation accelerated, reliability improved across the board because no manufacturer could afford to have the worst maintenance record. And the trucks kept getting bigger. WABCO responded to Caterpillar's challenge by doubling down on size. In 1965, they introduced the 120-ton Haulpack, the largest 2-axle rear dump truck ever built to that point. It was powered by a V12 Fairbanks Morse diesel making 930 horsepower, later upgraded to a GM 1000 horsepower engine. The hydraulic hoist cylinders were bigger than a man's torso. The tires cost more than a new car, and it was available in both mechanical drive and diesel-electric drive configurations. The 120-ton trucks found immediate customers in the massive open-pit copper mines of the American Southwest. These operations were stripping away entire mountains to reach ore deposits, and every increase in truck capacity meant less trucks needed to move the same amount of material. Fewer trucks meant fewer operators, less fuel, reduced maintenance. The economics worked at scale. But the diesel-electric version represented something more significant than just another drive system option. It was WABCO's acknowledgement that unit rig had been right. At very large capacities, electric drive offered advantages that mechanical transmissions couldn't match. Precise speed control on steep grades, regenerative braking that fed energy back instead of just burning it as heat, reduced driveline complexity, and the ability to run on overhead trolley power in sections of the mine with fixed routes. The partnership with General Electric that made this possible also created a strange situation. WABCO and Unitrig were competitors building trucks, but both were using GE's motorized wheel system. GE would sell to whoever paid, which meant the two rivals ended up helping refine the same drive technology. Competition made both companies better. Through the late 1960s, the big open-pit metal mines that had once been Euclid's exclusive territory became a battleground between WABCO Haulpack and Unitrig Lectra Hall. Euclid was still building good trucks, but GM's ownership had created problems. An antitrust suit filed in 1959 argued that GM's dominance in the heavy equipment market through Euclid was stifling competition. GM fought it for years before finally settling in 1968 by agreeing to sell Euclid to White Motor Corporation. The sale effectively killed Euclid's position as the industry leader. White didn't have GM's resources or engineering depth. The Euclid name continued, but the company never recovered its former dominance. That left WABCO and Caterpillar as the two giants fighting for market share, with Unitrig carving out a niche in electric drive, and smaller manufacturers like Terex and KW Dart picking up whatever contracts the big players didn't want. The corporate reshuffling wasn't finished. In 1968, WABCO itself got swallowed by American Standard Company, yes, the bathroom fixtures manufacturer. It was one of those conglomerate merger deals that made sense to shareholders and accountants, but left engineers scratching their heads. American Standard wanted to diversify into heavy equipment. WABCO wanted capital for expansion. The marriage was logical on paper. For the Haulpack line, the ownership change barely mattered. The trucks were still designed in Peoria, built in Peoria, and sold worldwide under the WABCO Haulpack name. Production continued expanding. Models got larger, 150 tons, 170 tons, then the massive 3200 series that started at 200 tons and eventually reached 250 tons. The 3200 was something special. 3 axles, 10 tires, 2,000 horsepower. It was the largest off-highway truck in series production, and it represented the logical extreme of scaling up the basic Haulpack design. The structural collar that had been a modest feature on the original 32-ton truck was now a massive steel structure that could support a dump body larger than most houses. The Hydrair struts were the size of telephone poles. The entire truck weighed 185 tons empty and nearly 435 tons loaded. And it all traced back to Ralph Kress's insight 15 years earlier that you couldn't just scale up a highway truck and call it a mine truck. You had to reconceive the entire machine from the ground up around the specific requirements of moving massive loads over terrible terrain at the lowest possible cost per ton. By 1970, WABCO could legitimately claim they'd done exactly that. The Haulpack was the benchmark by which all other mining trucks were measured. But benchmark status made you a target, and the competition was learning fast.
The 1970s should have been Haulpack's decade of dominance. By 1975, WABCO had built their reputation on reliability, their patents protected the crucial suspension technology, and their trucks were operating on every continent where mining happened. But success in the mining equipment business made you vulnerable in ways that had nothing to do with engineering. Dresser Industries was watching. The Dallas-based conglomerate had fingers in everything from petroleum equipment to railway supplies, and they wanted a bigger piece of the mining equipment market. In 1984, they bought WABCO's construction equipment division from American Standard, which had decided heavy equipment didn't fit their strategic focus anymore. Another merger, another corporate parent, another round of promises that nothing would change. For mine operators, the ownership transfer barely registered. The trucks still carried the Haulpack name. They were still built in the same factories by the same workers using the same processes. Dresser had enough sense not to mess with a successful formula. They rebranded the line as Dresser Haulpack, updated the model designations to reflect gross vehicle weight instead of arbitrary numbers, and kept building trucks. The model line now ranged from the 35-ton 140M to the massive 830E at 240 tons. That E meant electric drive, and by the mid-1980s, nearly every Haulpack over 150 tons was diesel-electric. Mechanical transmissions just couldn't handle the torque anymore. The drive shafts would have needed to be as thick as tree trunks. The differentials would have weighed several tons. Electric drive eliminated all that complexity. Diesel engine spins a generator, electricity flows to motors and the wheels, and the only mechanical components in the drivetrain are the wheel bearings. But while Dresser was consolidating the Haulpack line, something interesting was happening 8,000 miles away in Japan. Komatsu, one of Japan's industrial giants, had been building construction equipment for decades. Their smaller dump trucks were good, really good, and they were developing a reputation for reliability that gave Caterpillar fits in Asia. But they'd never broken into the large mining truck market where the real money was. The 100-ton-plus trucks that moved mountains required specialized engineering expertise Komatsu hadn't developed. Dresser had that expertise. Komatsu had capital and manufacturing capacity. In 1988, they formed a joint venture, Komatsu Dresser Company, or KDC. On paper, it was a partnership. In practice, Komatsu was positioning itself to eventually acquire the entire operation. For the Haulpak engineers in Peoria, the Komatsu partnership initially changed very little. They still designed trucks, those trucks still dominated the large capacity market, but they also started noticing Komatsu engineers showing up in Peoria more frequently, asking very detailed questions about design philosophy, manufacturing processes, and component sourcing. The questions weren't casual interest. Komatsu was downloading decades of American mining truck experience into their corporate knowledge base. They were learning what Ralph Kress had figured out 30 years earlier, that mine trucks required completely different thinking than highway trucks or even construction equipment. By 1994, Komatsu had learned enough. They bought out Dresser's remaining shares in KDC, making it a wholly owned subsidiary. The manufacturing remained in Peoria because moving that capacity to Japan made no sense. The engineering team stayed intact because Komatsu wasn't stupid enough to fire the people who knew how to design 300-ton dump trucks, but control had shifted from an American company to a Japanese corporation, and that meant changes were coming. The first change was gradual. Komatsu started developing their own diesel engines for the trucks instead of buying GM or Cummins power. The SDA 16V160, a 16-cylinder monster making 2,500 horsepower, went into the 830E and 930E. It was more fuel efficient than the engines it replaced, and more importantly, Komatsu controlled the entire supply chain. No more waiting for engine deliveries, no more price negotiations with suppliers. They made the engines in Japan and shipped them to Peoria for installation. The second change was the one that mining industry historians would mark as the end of an era. Around 1998, Komatsu quietly stopped using the Haulpak name on new trucks. The 930E introduced in 1996 was officially a Komatsu 930E, not a Komatsu Haulpak. Marketing materials still mentioned the Haulpak heritage for a while, but by 1999, even that was fading. The name disappearance made sense from Komatsu's perspective. They were trying to build a global brand identity, and having different product names in different markets was confusing. Every truck they sold should immediately be recognized as a Komatsu. But for the engineers who'd spent careers developing Haulpaks, it felt like watching an old friend's name being erased. The trucks themselves didn't change. The 930E that launched the Komatsu branding was still fundamentally a Haulpak in everything but name. Deep V body, hydropneumatic suspension, kinked frame to minimize stress concentration. Ralph Kress's design principles were still there, baked into the structural DNA, but they were now wrapped in Japanese corporate identity instead of American industrial heritage. Unit Rig had already lost their independence by this point, absorbed first by Terex and then by Bucyrus International, before finally ending up as part of Caterpillar when Cat bought Bucyrus in 2011. Euclid was a shadow of its former self, passed from White Motor to Daimler-Benz to Clark Equipment to Volvo before being absorbed by Hitachi. The mining truck industry that had been a battleground of American manufacturers in the 1960s was now dominated by Japanese companies and European conglomerates. Caterpillar remained, still building trucks in Decatur, Illinois, and still fiercely defending their position as the only major American mining truck manufacturer. Their 797 series, introduced in 1998, was a direct response to Komatsu's push for dominance. A mechanical drive truck, Caterpillar refused to abandon mechanical transmission, rated at 400 tons, powered by a monstrous 3,793 horsepower diesel engine. Where Komatsu had embraced electric drive, Caterpillar stuck with what they knew: massive gears, enormous torque, and enough power to climb a mountain while carrying another mountain on your back. The rivalry between Caterpillar and Komatsu shaped the mining industry through the 2000s and beyond. When Komatsu introduced the 980E in 2008 with a 400-ton capacity to match the Cat 797, Caterpillar responded with the 798AC trolley truck. Back and forth, model for model, each company trying to prove their approach was superior. But under that rivalry, both companies were building on foundations laid decades earlier. Komatsu's trucks trace their lineage directly back to the 1957 Haulpak and Ralph Kress's insights about suspension, frame design, and body shape. Caterpillar's trucks incorporated lessons Kress had taught them in the 1960s when he designed their first mine truck. The engineering approaches differed. Komatsu favored electric drive for its controllability, while Caterpillar insisted mechanical drive was simpler and more reliable. But the fundamental configuration remained remarkably consistent. Short wheelbase, deep body, sophisticated suspension, structural elements designed to handle shock loads without cracking. Every modern mining truck, whether built by Komatsu, Caterpillar, Liebherr, Hitachi, or anyone else, followed principles established when Eisenhower was president and the biggest truck on the market carried 50 tons instead of 400 tons. Ralph Kress lived long enough to see his designs validated by an entire industry. He died in 1995 at age 91, just as Komatsu was preparing to drop the Haulpak name. The National Mining Hall of Fame inducted him posthumously in 2001, calling him the father of the off-highway truck. The recognition was appropriate but late. Every mining truck rolled out of every factory in the world was a descendant of the machine Kress had conceived in 1955. The specific companies had changed, the corporate ownership had shifted through mergers and acquisitions, the capacities had increased by an order of magnitude. But the fundamental concept that mine trucks required different engineering than anything else on wheels, that driver comfort directly affected productivity, that suspension was critical, that frame design determined longevity, all of it traced back to one engineer who'd been willing to throw out conventional thinking and redesign the mine truck from the ground up.
Today, the name Haulpak exists only in mining industry memory, and the fading paint on trucks too valuable to scrap but too expensive to rebuild. A 40-year-old Haulpak sitting in a South American copper mine, still hauling 100 tons a shift, still riding on Hydrair suspension struts that were patented when Kennedy was president. The operator doesn't care about the name. He cares that when he hits a rock the size of a refrigerator at 15 miles per hour, the cab doesn't try to shake his teeth out. That's Kress's legacy, and it's more permanent than any corporate logo. Walk onto any major mine site in the world today, Chile, Australia, Indonesia, South Africa, anywhere rock gets moved at industrial scale, and you'll see trucks that look remarkably similar regardless of manufacturer. Komatsu 930Es sharing haul roads with Caterpillar 797Fs, Liebherr T284s, and Hitachi EH5000s. Different paint schemes, different badges, different corporate heritage, but the same basic configuration. Short wheelbase, deep V body, hydropneumatic suspension, structural frame design to distribute stress rather than concentrating it. Some engineer at Liebherr didn't independently decide that configuration was optimal. Someone at Hitachi didn't rediscover through trial and error that short wheelbases and sophisticated suspension systems were the right answer. They looked at what worked, reverse engineered the principles, and designed around Komatsu's patents the same way everyone else had designed around WABC's patents 50 years earlier. The modern trucks have gotten absurdly large. The Buscurus MT6300 AC, introduced in 2008, could haul 400 tons. 400 tons. That's 800,000 pounds of rock moving at 40 miles per hour on tires that cost $40,000 each and last maybe 6 months in hard service. The fuel tank holds 1,000 gallons. The engine makes nearly 4,000 horsepower. A light pole hit by one of these trucks wouldn't even slow it down. The pole would just disappear. But scale up the dimensions all you want, and you're still looking at Ralph Kress's truck. The proportions are the same. The suspension concept is identical. The body shape follows the same deep V principle. The frame design uses the same stress distribution approach. You could show Kress a photograph of a modern 400-ton truck, and after he got the shock of the sheer size, He'd recognize every major design element. The evolution from that first 32-ton Haulpack in 1957 to a 400-ton behemoth in 2025 wasn't random. It followed a logical path established by one man's insight that mining trucks required fundamentally different engineering than anything else on wheels. Every company that entered the mining truck market had to learn that lesson, either by licensing Kress's patents or by designing around them. Either way, they validated his approach. Caterpillar still builds mechanical drive trucks in defiance of the industry trend toward electric drive. Their engineers will argue passionately that mechanical transmission is simpler, more reliable, and easier to maintain in remote mine sites where electric motor specialists might be days away. And they might even be right. But those mechanical drive trucks still use sophisticated suspension systems, still have deep V bodies, still follow design principles that reduce frame stress. Kress's influence appears in their trucks too, just filtered through Caterpillar's corporate preference for gears over generators. The mining industry has changed dramatically since 1957. Automation is eliminating drivers. Some Komatsu trucks now haul loads without anyone in the cab, following GPS routes and responding to remote commands. Onboard computers monitor every system in real time, predicting failures before they happen. Modern mine trucks have more computing power than the Apollo spacecraft had when it went to the moon. But they still need suspension systems that can handle 15 tons of rock dropped from 10 feet. They still need frames that won't crack under cyclical loading. They need bodies that allow material to flow out completely during dumping. The technological dressing has changed, but the fundamental engineering challenges are the same ones Kress solved in 1957. There's something appropriate about Komatsu carrying forward the Haulpack legacy, even after retiring the name. The best ideas in engineering transcend corporate boundaries and national origins. A good design concept doesn't care whether it's painted in WABC colors or Komatsu yellow. What matters is whether it works reliably in the harshest operating environment industrial equipment faces. Mine trucks exist in a mechanical hell. Temperature swings from -40 to +120. Dust that works its way into every bearing and seal. Shock loads that would destroy highway trucks in hours. Operators who run the equipment 24 hours a day, 7 days a week, with maintenance conducted only when something breaks. Any component that survives that environment must be fundamentally sound. The Hydrair suspension system survived because the concept was fundamentally sound. Hydropneumatic struts work. They work better than anything else anyone has developed for this application in 70 years. Companies have tried air springs, tried progressive rate mechanical springs, tried exotic materials and computer-controlled damping. Some improvements have stuck. Nitrogen-charged accumulators are more sophisticated now, seals are better, maintenance intervals are longer. But the basic concept Kress patented in 1957 is still the industry standard. That's how you measure true innovation. Not by whether your name stays on the product, but whether your ideas become so ubiquitous that everyone forgets they weren't always obvious. Short wheelbase in mining trucks? That's just common sense. Deep V-shaped bodies? Obviously the right approach. Sophisticated suspension systems? Every manufacturer uses them. Except none of it was obvious in 1955, when Ralph Kress sat down with a blank sheet of paper and decided to rethink everything about mining trucks. Euclid dominated the market with trucks that used completely different design principles, and they were profitable doing it. Kress had to convince WABC to invest millions in an unproven concept based on his conviction that the industry was doing it wrong. He was right. The entire industry adopted his approach within a decade. That's the purest validation an engineer can receive. Not awards, not recognition, but imitation. When your competitors stop arguing with you and start copying you, you've won. The mining industry today moves more material in a day than would have taken a year in 1957. The trucks are bigger, the mines are deeper, the operations are more sophisticated. But the trucks hauling that material are direct descendants of the first Haulpack, and the engineering principles enabling their existence were established by one man who understood that sometimes you have to throw out the rulebook and start over.
Ralph Kress revolutionized mining trucks by refusing to accept that they had to be built the way everyone else was building them. His insight changed an industry. His designs outlived his company's name, and Every mining truck working today carries his legacy in its frame, even if the badge on the hood says something different.